I'm Casper, a product manager at Iterative. It's a very global company, but personally I'm based here in London. And yeah, this talk targets machine learning engineers and data scientists. I know the title probably sounds quite ambitious given that, and quite opaque. So before we jump into it, I think I should take a step back and discuss the actual real problem as I see it. So I think there are two distinct groups of people in industry. You have practitioners and you have engineers. And one of the issues is these two groups like playing with different things. And even in an ideal scenario, each group gets to play with only what they like playing with. And then they communicate to collaborate. But even then, the communication itself is often a bottleneck. If you have to send an email to another team and then wait for a response, if that's how your machine learning pipeline runs, then you're not really doing continuous integration. It's more like email integration. We even had an earlier talk from Johnson & Johnson talking about when you hand over to another team and they throw out half of your code because it just doesn't work for them, right? So this is slow and painful. One of the potential solutions I've seen in industry is to sometimes meld teams into some sort of cyborg. Harsh realities is that means people don't have enough time to develop expertise in any particular area. And again, it's slow and painful and underwhelming. So the alternative I propose here is you as a machine learning engineer or data scientist can develop your models on your laptop, and at some point you run out of storage space or compute. You need to migrate to a bigger data set. And at that stage, you can move to the cloud, where you have more compute, more storage. But the key here is you shouldn't need an extreme level of expertise to do this. Okay, so this is the key take-home from this talk that I'm trying to push at, which is basically lowering the entry barrier. So taking a step back, what do I really mean by the cloud? Just to make sure we're all on the same page. The cloud is just a fancy way of saying renting hardware from one of the usual suspects, Amazon Web Services or Microsoft Azure or Google Cloud. You rent hardware that you control over the internet, and you never physically see it. So that's maybe an OK definition for a DevOps person. But harsh realities in real life, to a machine learning data scientist who just, I just want to run a model, right? This is just more trouble than it's worth. It's slow, it's painful. If I have to read documentation or switch careers. So what do I mean by it's more trouble than it's worth? Well, let's take a look at the traditional way of using a cloud, using the command line interface. Firstly, you have to sign up for a cloud account with one of the usual suspects. How do you log in? Well, it's not like an email account. That would be too easy if it's just a username and password. No. You have access tokens, which are automatically generated passwords, which are like 300 characters long. And you don't just have one access token, you have 2 or 3 of these, and you have to copy-paste all of them. And then, of course, how do you actually use them? Well, you have to install a tool, a command line tool first, and it's not easy to install it. You have to probably first install Python and then use Python to install the tool. And this is OK for a DevOps person. Yeah, sure, just create a new Python environment and pip install AWS CLI. Yay. If I just want to run a model, this is too complicated. And of course, once you have the tool and you have your access tokens, you then have to read the documentation, because there's a million subcommands and a million options. And that's usually the point where you start questioning your life decisions and having nervous breakdowns. You might say I'm being harsh here. I'm talking about command line interfaces. These companies, Amazon, Google, Microsoft, they're known for having web interfaces and nice ways of doing things, right, where you point and click. So OK, fine. Let's take a look at the graphical user interface, the GUI. Still have to sign up for an account. You don't need access tokens or anything. Username and password is pretty much OK, because you're logging in into a browser. Sometimes you have an account ID, which is like a second username. But OK, 2 usernames and a password. No access tokens, no proprietary command line tool. And then you just point and click in your browser. Here's a screenshot of what one of those interfaces looks like. It's totally very intuitive. You don't have a million buttons. It's not easy to accidentally kill somebody else's machine. And it's not easy to accidentally request 16 GPUs and find out only at the end of the month when you have a $10,000 bill surprise. I definitely don't know experts who regularly do this. I've never personally done this myself, ever. Never, totally. I'm being sarcastic, sorry. So the end result is usually the same in terms of frustration, right? So the solution I'm proposing here is easy, or at least easier to use. Also, Some of the other solutions out there make the cloud easier and more accessible, but they charge you a premium for this. I don't think you should be paying extra for this. I think it should be free and open source. So that's all that I'm going to cover here. Speaking of which, it would be great if you don't lock yourself into one of these cloud providers. Maybe AWS is cheaper today, but tomorrow Azure might be cheaper. So ideally, just by changing one line of code, you can switch between them, right? So let's be agnostic. And the secret sauce over here is we're going to replace DevOps and engineering with GitOps, effectively. We're going to codify some of our pipelines. Now, I know some of you might be thinking, oh, please, not Git. Data science and machine learning engineers kind of don't like Git, and I fully sympathize with this. So I'm not going to talk about the most difficult aspects of Git. We don't need branching strategies. We don't need merge conflict resolution, right? You don't need to spend time on this. All that I'm talking about over here is the most basic aspects of Git, which is just the code version control. And in fact, it's only 3 commands: add, commit, push. Probably everyone here is familiar with them. And in fact, you don't even need to run these commands. You can just use the big blue button in your code editor of choice. This is a VS Code screenshot, but whatever. Click that button and it runs those 3 commands for you. So the idea here is why we're using Git is beyond what you've already been told. You've been told Git is good for version control, it's good for reproducibility. The reason I'm using it is because it's then very easy to push your code to one of the standard hosting providers, github.com or GitLab or Bitbucket. And the nice thing about them, it's a bit like OneDrive or Dropbox, but for code. I'm sure most of you are aware of this. The nice thing is they have bespoke features tailored to dealing with your code. One of the great features that they have is built-in CI/CD, which is another acronym: continuous integration, continuous delivery, which is a verbose way of saying they can run your code. Now, internally, they're running things on their own cloud. Like GitHub Actions has its own flavor of Microsoft Azure that it's running your code on. And the nice thing is you don't have to set this up yourself. You don't need access tokens. You don't have to sign up for a separate cloud account. It just runs. It's great. There are caveats. So they have limited storage. They have limited compute power. It's pretty much similar to running things on your own laptop. So you're limited by that. You can pay them for more compute power. They're adding GPUs as well, so you should be able to pay for that as well. But they will be a premium because it is easier to use. And plus, it can still be a little clunky. Maybe you have Amazon data sets, and you don't want to import them into some other CID system, right? So the nice thing is that all 3 of these CI systems have self-hosted runners as an option, which is a fancy way of saying you can bring your own cloud infrastructure. You don't have to put up with the stripped-down version of Azure and GitHub Actions. You can bring your full-blown Azure cloud or AWS, or even on-premise. If you have systems online, you can hook them in. From your own company physically present, you can hook them into GitLab CI/CD, Kubernetes as well, fully supported. So I know overall maybe this seems quite complicated. There are 4 things on the slide. Can a data scientist or machine learning engineer really set all of this up? The key take home over here is that it's a one-off setup. So once in your project's lifetime, you set all of this up. And then every time you want to run a new experiment, you make some changes to your code, you click the big blue button. And everything else happens completely automatically. OK, so I hope I'm convincing some people who are maybe against GitOps or against using Git for anything remotely complicated that maybe this is better than DevOps. So as a quick recap, we're going from you as a machine learning data scientist, modifying code and data on your laptop, clicking the commit button, and some magic happens in the cloud. We don't need to care about this. And within a few seconds, you get wonderful reports in your web browser, real-time training loss metrics, confusion matrices, a table of results. And that's our end goal, having this happen in just seconds. So let's look at step 1. I'm going to go through our 4 steps in detail. Okay? Starting with Git, yes, you probably know that you have to install Git. You can do it from the Git website. Git SCM stands for Source Code Manager, more acronyms. Anyway, if you have an existing project, you do git init inside that project directory on your local laptop to initialize it. That turns your directory into a repository. I'm sure most of you know this, right? You add and commit things as and when you change them. I think you should think of this as good science rather than engineering. The way I think of it is this is the digital equivalent of a lab book. If you ever need to convince people to use Git, right? A chemist makes changes to the experiment in the laboratory, and then they make a note of it, right? this is the digital equivalent. So you should do this as a good scientist, right? Step 2, okay, we want to push this somewhere. So if you have a repository on your laptop and you now want to link it to one of these websites, you have to create a new empty repository online as well. Bit counterintuitive, you have to create things in 2 places, but yep, that's what you do. There's instructions of then how you link your remote repository to your local repository. It's usually copy-paste one command, like git remote add the URL. So that's a one-off setup. Once that's done, your local and remote are linked, and then every time you make a change to your experiment, you just git push or click the button in your code editor. Right, so here's where the real secret sauce happens if you want to actually run your code automatically. Now, you could look up the documentation for GitHub Actions or GitLab CI and Bitbucket pipelines, but there's pages of this stuff, and it's not really tailored for a machine learning engineer, let's say. So I'd recommend you just go to cml.dev. There's really nice user guides over there. Getting started is a great place. And there are different tabs for whichever CI system you've happened to have chosen. And all you really have to do to configure them is just add a single config file, a YAML file, to your repository. And that lets your CI system know exactly how to run things. And these files are fairly human readable. I think a machine learning engineer or data scientist can actually understand these. So here's an example. This is the entirety of a GitLab CI config file. Yep, you can name your experiment, train, and report in this case. You can use any Docker image. In this case, I'm using a CML image just for convenience, but you can use your own. Pip installed requirements. Requirements are defined in your repository, presumably. You can run a Python training script or any other programming language that you happen to be using. And you can even build Markdown reports. So you can insert tables into this thing. You can generate images and training loss plots and things and insert those into your report in just normal Markdown syntax. And then use CML to actually publish this report. Where does it get published? Well, it gets published into, well, in this case, your GitLab interface. So on the website, you get this mini confusion matrix, but whatever else you want plotted there. And it can update in real time as well as your script is running, or you could just publish a report right at the end of training. So yeah, really nice way to collaborate and share the results of your experiments. And if you need more power and you want to bring your own runners, your own cloud, basically, you can take a look at the self-hosted section. Again, you could probably set this up yourself using AWS or Azure, or their own proprietary solutions, but it's great if you have a built-in copy-paste. So the workflow is very similar. You copy one of these config files depending on your system. The only difference here is, okay, so this is the same GitLab example from before, but we have an extra section at the top, which is going to provision, in this case, cloud equals AWS. So it's going to provision an Amazon Web Services machine somewhere in the cloud. And it'll be a GPU instance. And then the rest of this workflow will execute on that AWS instance. Now, there's a lot of complexity which went into it. It took a lot of effort to actually implement this in a nice, clean way. You might even notice there's a cloud spot option over there in our script at the top. For those of you who don't know, spot instances are 70%-ish cheaper than your normal cloud instances. But the disadvantage is they could shut down at any time. They could shut down in 5 minutes or a day. You don't really know. So that's why they're 70% cheaper. The great thing with CML is we know if something's about to be shut down, and we automatically request a new spot instance. So instead of losing your machine learning training halfway through, it's more like pausing your training, and then maybe an hour later, a spot instance becomes available again, and your job continues. So you get 70% savings, and you don't have to rewrite all of your code. Right, OK, so yeah, I recommend going to the CML website to get these code snippets. I don't expect you to copy-paste this right now. You might be wondering about authentication. How does CML actually know to create AWS instances? How does it have permissions? You do have to copy-paste your access tokens to, in this case, GitLab, but there's different methods for GitHub and Bitbucket as well. It's a one-off thing when you set up a project. Once it's set up, you don't have to touch it again. And again, I recommend you just go to our website for figuring out how to do it for all of the different combinations of, are you using GitLab? Are you using Amazon? What are you linking together? Summaries are all on CML Dev. Right, so as a recap, our end goal is clicking a button on your laptop, and then as if by magic, you have these beautiful reports that happen to have been generated from some cloud instance running GPU servers, and they get provisioned and terminated completely automatically. You don't have surprise $10,000 bills at the end of the month, right? It scales really well as well, so if you've committed 10 times and you're running 10 experiments, sure, there's 10 machines provisioned in parallel. Great. OK, so hearkening back to the original problem, we've gone from this annoying friction, collaboration issue between different teams and lack of communication or lack of understanding to automation with one button. Right, so we're iterative. I've only talked about one of our tools, CML, but we have other things as well to do with data versioning and pipelining and reproducibility. And yeah, just look for the colorful owls, and we have a booth outside, and we'll be happy to chat. Thanks.